Acetylcholine will bind to receptors for acetylcholine, and there's two main types, muscarinic and nicotinic. So those are acetylcholine agents. Acetylcholine will agonize muscarinic or nicotinic receptors. Muscarinic is sometimes referred to as metabotropic because they're involved with basic metabolic functions. And nicotinic receptors are sometimes referred to as ionotropic because they cause the flow of ions. That's actually not unique to a nicotinic receptor. There's many, many different types of ion channels, even with muscarinic. But this ion flow in nicotinic receptors is particularly prominent, important to heartbeat rate, to the state of vascular vasodilation or vasoconstriction. So here's a good schematic. Let's go on now and talk about cholinesterase inhibitors. So we're still talking about cholinergic agents and neurotransmitters that fall under the category of acetylcholine. Cholinesterase is an enzyme that will degrade acetylcholine. Once the neurotransmitter is released into the synaptic cleft, if we look in this area again here, once the acetylcholine is released, in almost all cases, the neurotransmitter does its job and then is recycled and taken back up into the very neurotransmitter that released it and put back into a little vesicle, packaged up again to be used over and over. Alpha and beta adrenergic receptors are the main types of receptors on target cells that will receive adrenaline, also known as epinephrine. Alpha and beta receptors have some overlap and some differences. We see that in the liver, both alpha and beta receptors will promote glycogenolysis, meaning breaking apart glycogen that's stored in the liver, that starchy substance that's stored, to release the compounds and ultimately get your blood sugar up. So this makes sense if our body is running low on blood sugar, if it's the middle of the night, if we're exercising, we're not eating, we've depleted our blood sugar reserves. There's a lot of starch stored in the liver for fast breakdown to get blood sugar up. Here's a list of plants that I'm aware of that bind to opium receptors, some of which are not in the poppy family. Black cohosh, for example, Actea, is not in the poppy family. This probably explains why black cohosh is used for pain, for fibromyalgia, premenstrual headaches, and some different types of rheumatic musculoskeletal conditions. This wouldn't be the only reason why, purely because it's an opiate, but it's one of the factors contributing to its analgesic anodyne effects. Some of you might be aware of kratom. It's not in the poppy family, mitragynine. It can be used even for opiate withdrawal, heroin cessation, to transfer onto kratom. It's addictive itself, and I'm not really recommending we go around giving people kratom all the time for pain. Going on to anandamide. I think I only have one or two slides here. Ananda is the word in Sanskrit for bliss. And the researcher who first discovered anandamide was of Indian descent, and in the Sanskrit language, he was aware of Ananda, and he got to name the neurotransmitter receptor, and hence anandamide contributes to happiness, bliss. Endocannabinoids and anandamide receptors are connected. Endocannabinoids can impinge upon anandamide. Anandamide agents and anandamide containing plants or ligands that bind anandamide receptors. Anandamide is one receptor in the endocannabinoid pathway.